A good understanding and awareness of process safety and the management of safety critical elements, SCEs, is vital to the prevention of breaks in containment and ultimately in the potential for a major accident or incident. Understanding your role in how we manage process safety and safety critical elements determines whether our staff go home safe at the end of the day. Everyone has a part to play and a responsibility to sustain good process safety management practices from field operators and maintenance teams to the design engineers, inspectors, workshop testers or procurement teams. Process safety and SCEs. SCEs are equipment, hardware or control systems that are effective barriers against the release of hazardous substances that could lead to a major accident or that mitigate the consequences of those. Examples of SCEs include fire and gas detectors, deluge systems, relief valves, or emergency shutdown valves and systems. The management of these safety critical elements spans across the entire plant. This means that we have to be systematic in our approach to continually monitor and manage the life cycle of the identified SCEs to ensure that they are designed, maintained, assured, verified, and aligned to our performance standards. Bow ties. So how are these safety critical elements identified? The process starts by identifying potential hazards. Then risk scenarios are developed and assessed as part of the asset HSE case. Once complete, a bow tie analysis is used to develop a picture of how multiple scenarios could cause a loss of containment of the particular hazard and what barriers are in place to prevent it and to mitigate its fatal consequences. The hazard itself is the first thing that is defined on the diagram, and it is a substance or situation that can cause harm. The left side of the diagram is populated with all credible causes that may lead to a release or loss of control. The right side of the bow tie deals with what happens after a loss of control and how the scenario might escalate into different consequences. For instance, if the flammable gas is released and finds an ignition source, it could lead to a fire. Embedded throughout the bow tie, both on the right and left sides, are SCEs that underpin how to prevent, control or mitigate the major accident hazard event. This sounds pretty simple when using a diagram, but how does this translate to real life when you're working on a live processing facility? Let's give you a visual of how these SCEs work when you're in the field to provide multiple layers of protection. Working on a processing and storage facility means that hazardous substances are all around you. You're protected, however, by multiple barriers of protection. The safety critical elements we mentioned earlier are components within these barriers. Imagine the safety barriers like walls standing between you and the hazard. The walls are built of blocks. Each block represents the safety critical elements keeping you safe. The failure of one element doesn't necessarily mean that there will be an accident, but on any given day, there is the potential for things to escalate to a loss of control. All that is required for a major incident is for the holes in the safety barriers to line up. The effects of neglecting the building blocks of those safety barriers are catastrophic. SCE life cycle. Now that we've reviewed how safety critical elements, SCEs, are identified and how they are a subset of major accident hazard control measures, it's important to discuss the life cycle management involved to ensure that their performance standards, PSs, are complied with and that the maintenance routines, inspection and testing and performance histories are systematic in keeping the SCEs reliable and in good condition. How we complete the inspections and their frequency are vital to managing the life cycle and includes having a clear and defined approach for nature and frequency of examination and testing, roles and responsibilities, completion and maintenance of records and logs. Our process safety rounds are part of this process. The field checks we require you to complete help to underpin the performance and reliability of our safety barriers in addition to the formal inspections and preventative maintenance activities, or PMs, as scheduled in ERP. We undertake this task regularly, and they have proven to be very helpful. Common reported findings include leaks, oil, water, air, improper installation of car seals, faded tags, corroded equipment, cables observed fallen from the cable tray, earthing cables not connected, damaged pressure gauges. The timely inspection, reporting and remediation of these types of findings ensures that we're all helping to sustain our process safety management standards.